Okay, use law of cosines. We need to know what law of cosines says, so I'm going to write it up top here. Okay, it says c squared equals a squared plus b squared, which is like what our normal uh, Pythagorean theorem is, right? But since it's not a 90 degree, it's not a right triangle, we say it includes also c squared equals a squared plus b squared minus 2ab cosine c. Now, if you're interested in a proof to see why this works, there is a proof in the book, but we're just going to work with it right now. And if you want to see it, you can ask me and we'll go over it. But what are we dealing with here? Law of cosines to find. They're telling us a triangle, FGH, and I'm going to sketch it. I'm going to sketch it because a visual representation is always so much easier to imagine. Okay, now, because it's a sketch, don't expect it to look like the actual triangle would look if you knew what it was, but there it is. We're going to label it F, G, H. And when we're using law of cosines, you will hopefully become comfortable with the idea that unlike law of sines where you do two sides, two angles, here we're doing three sides, one angle. Okay, and that's going to tell you which thing we're going to be dealing with. Okay, and this. So essentially, you will know three pieces of information. You'll be asked to find the fourth. So let's write in what we know. We know that h is 22 feet. Put the feet on later. We know that g is 5 feet. We know that angle F is 50 degrees. And what they're asking for is find the measure of F. F equals what? So as you can see, we've got 1, 2, 3 sides and an angle. When I say we have 3 sides and an angle, we actually don't have the third side, but we're using it in our problem. So that's what I mean by having it. We have to use it. Okay, so how do we set it up? Well, how do we know what C is? That side that's, look up top, that side that is all by itself on the left-hand side of the equal sign. Well, that's going to be the side that's across from the angle you know. And across from the angle that we know is F, and that's what we're trying to find. So we can then write it as, instead of saying C squared, we can say F squared equals, and then plug in the sides we know. 22 squared plus 5 squared minus 2 times 22 times 5, the two sides that we had that we used over here, already on the right hand side of the equal sign, that 22 and 5 appear twice, 22 and 5, times cosine of the angle, and the angle in this case is 50. Now, you might be sophisticated enough to realize that you can actually just type all that in your calculator. You can get F squared equals, or really, because once you use cosine and you turn it into a number, it's going to be F squared is approximately equal to, and I'm going to type that whole string of numbers in. Okay, there's nothing on the right hand side that we're finding. It's not like we have to find the angle, so we can just type it all in. We can say 22 squared plus 5 squared minus 2 times 22 times 5 times cosine of 50, close parentheses, equals, and I get this number that I'm not yet going to round off. Why can't I round it off? Because we actually need to square root it first. F squared equals this number, roughly 367.586 7259. You don't have to write it down here like this, but I'm just writing it down roughly is that. And so I'm going to say second, and then when I hit my square button, the second of the square button is the square root button. And then if you have a TI-84, you can just go up and select that number and hit enter. TI-83s won't allow you to do that, and you have to manually enter the number. And you hit equals, and you get 19.17, or F is approximately equal to, if they say rounded to the nearest whole number, 19.17 rounds to 19. And that is the answer for this one, C. Okay? Alternatively, you could have said straight away, you could have said F is equal to the square root of all of that, 22 squared plus 5 squared, etc. Okay? You could have typed all of that straight away into your calculator, and that would have jumped you to the answer straight away. And I don't discourage you from doing that. That's a perfectly fine thing to do. So there you go. There's that one. Let's do a few more. Okay, so for this one, find the measure of A. We're going to do the same thing. I'm going to just rewrite the same formula up top, okay? I'm going to write C squared. And remember, when we say C squared, just to simplify it so that you're not using multiple formulas for each particular side you're looking for, C is, in our case, whatever is across from the angle that you know. And okay, so C squared equals A squared plus B squared minus 2 AB cosine C. Okay? Who cares? Well, what are we going to do now? What we're going to do is we're going to figure out which side is C. Well, C is the side opposite the angle, always. So we're going to say that's A. So now we'll just call it A squared, okay? Doesn't matter. And in fact, let's do this one. Let's say A is equal to the square root of. Since we're eventually going to square root it anyway, we might as well just type it all into the calculator exactly how it's going to be. And then, of course, the other two sides over here are just the sides they gave us. So we have 8 squared plus 11 squared minus 2 times 8 times 11, which instead of putting parentheses around them, you could just hit the times button if you are on your typing in your calculator. Cosine of 32.2. And then you get A is approximately equal to, and now let's type it all the way in your calculator. Hit the second button. And then the x squared, which will give you a square root symbol, and you can hit 8 squared plus 11 squared minus 2 times 8 times 11 times cosine of 32.2. Close that parentheses, hit enter, and what you see is 6.00583.073, or just 6. Short answer, 6. Okay, easy. That's when you're finding a side. When you're finding an angle, it'll be a little bit more tricky. Let's see what we got coming up. Okay, here we're finding an angle. So we're going to write the same thing out, but it's going to be a little bit more of a complicated thing. Just it'll take a bit longer. Okay, so we'll say C squared equals A squared plus B squared minus 2AB cosine C. And when we plug those numbers in, how do we know what is the C value that is going to go on the left-hand side? Well, what angle are they asking for? They're asking for us to find angle A. And so therefore, that's the angle we're dealing with, and the side opposite it is going to be what we call C. So we will say 23 squared equals 41 squared plus 27 squared minus 2 times 41 times 27 times cosine C. Okay? Now here's the bit. Because we're isolating cosine C, we actually first need to calculate all of these numbers. There's a way to do it, and I can show you the way to do it in just a moment if you care to, but this might be the best way for most of you. So I'm going to show you this. We're going to do 23 squared, and we get 529. So I'm going to write that in there. 529 equals 41 squared, 1,681, plus 27 squared, 729, minus 2 times 41 times 27 is 2214. And remember, that's 2214 times cosine C. That's not a free number sitting by itself. It's not a constant that you can combine. What can you combine? You can combine this and this, because those are constants that are just sitting there free and they can be combined. So let's do that next. We still say 529 is equal to 1,681 plus 729 equals 2410 equals 2410, 2,410 minus 2,214 times the cosine of C. And again, can't stress this enough. You're not allowed to do this. You can't do that subtraction. That is not just a minus 2,214 with nothing attached to it. This is a coefficient of this, so they become unlike terms. So what do? We can subtract 2,410 from both sides, minus 2,410 equals, and I'll write this below, now we got to do 519 minus 2,410 equals negative 1,881. Negative 1,881 equals negative 2,214 times cosine of C. And then in order to isolate the cosine of C, we take this side and we divide it by the number that's in front of it. And that means that we've got to take this side and divide it by the number that's in front of that cosine C as well. Divide both sides by the same thing. And you get cosine C is equal to this ratio. I'm going to drop the negatives. You don't have to. I'm just going to simplify that into that. If they both have negatives. And then, how do you find the angle from the ratio? You say inverse cosine of the ratio. Equals the angle. And then we say that angle is approximately equal to whatever we get when we do inverse cosine of 1,881 divided by 2,214. And we get 31.83 something something. 31.8 approximately when we round to the nearest tenth of a degree. That's A. Now, I'm going to show you on the next slide what you could do if you wanted to just have a formula for finding an angle straight away. I'll show you in a second. Okay. The first thing I'm going to do in order to show you that formula that you could plug it all in straight away is to write this down. Okay. First of all, we'll sketch this out in a second. Let me just write this down. If we had our original formula of, and you know what I'm going to do? I'm going to zoom in to this area right here. I'm going to do all this right up here and then zoom back out again. Okay. If we had c squared equals a squared plus b squared minus 2ab times cosine c, you could say, I'm going to subtract away from both sides. I'm going to subtract away from both sides. I'm going to subtract away a squared to get c squared minus a squared equals that. And then I'm going to subtract away b squared. And you would get c squared minus a squared minus b squared equals negative 2ab cosine c. And then divided both sides by negative 2ab. What you would get, and I'll write it below it, is c squared minus a squared minus b squared divided by negative 2ab will equal cosine c. And then we could say the inverse cosine of that ratio, c squared minus a squared minus b squared, all over negative 2ab, would give you angle C. Okay? And let's zoom out and say, okay, what that is telling us then, and it's not like I'm suggesting that you use this, because you'd have to know how to write that formula, but I'm going to write it over here on the side. Then the formula becomes inverse cosine of c squared minus a squared minus b squared all over negative 2ab. That would give you angle C. And you could use that if you wanted to. You could say inverse cosine of, and then type in the actual numbers themselves. Okay? I'm going to keep doing it the other way though. Like some of you might say, oh yeah, like there is an actual, like you can rewrite the formula in order to be able to say, let's isolate the variable within the formula before we plug in the numbers. You could do that. It's a little tricky though. It's a little tricky. So sometimes for ease of use, instead of coming up with yet another formula, and of course we wouldn't give this formula to you, you'd have to develop it yourself. Let's say instead of that, and I'll leave that right there, just as a calculation in case you want to see it. Instead of doing that, let's just go back to what we know, which is this. C squared equals a squared plus b squared minus 2ab cosine c. And then we're going to sketch out a triangle over here, and we're going to see what we know. Okay. They tell us we're doing JKL, so let's use those letters. That's J. This is little side J across from it. This is big K. This is little k across from it. This is L, and this is little l across from it. Okay. What do we know? We know that little j is equal to 12. They're telling us that. Equals 12. And k is equal to 9. and L is equal to 9.75. And they're asking us to find angle J. They want to know about angle J. If they want to know about angle J, then the side opposite 12 is what we're going to plug in for the C value. Okay? And so let's start plugging in and solving this. We're going to say then 12 squared, because that's opposite from the angle J that we are looking for, equals, and then the other two sides, 9.75 squared plus 9 squared minus 2 times 9 times 9.75 cosine C. Or really, instead of saying it's cosine C, we actually know what angle it is. It's J, so we'll call it cosine of J. Got it? Now we're going to sort out these numbers. 12 squared, 144. 9.75 squared, don't think I know that one. And we're going to write all of the decimals, even though it seems like you think we could round them. We're not going to round anything yet. It's a bad habit to round things early. Okay, plus 9 squared, 81, minus 2 times 9 times 9.75 equals 175.5. So minus 175.5 times cosine J. Okay? We can combine these two values because they're free, they're constants. 95.0625 plus 81. So we get 144 equals 176.0625 minus 175.5 cosine J. And what are we allowed to subtract? We can subtract this 176. We'll subtract it from this side first because I know it's going to stick off. Minus 176.0625 and minus 176.0625. What do we get? 144 minus 176.0625 equals negative 32.0625 equals, they cancel out on that side, leaving just negative 175.5 cosine J. And what are we allowed to do now? What should we do now? We should divide both sides by negative 175.5. And we get cosine of J is equal to, you could keep those negatives if you wanted. I'll leave them there this time just so you can see that you can actually still keep them there. Negative 32.0625 divided by negative 175.5. And then we can say, okay, if that's what cosine of J equals, then inverse cosine of that ratio, negative 32.0625 over negative 175.5 equals J. And then, I know I'm running out of room here, I'll write it right here, then therefore J is approximately equal to, as an angle, what do we get when we do inverse cosine of negative? Negative button is on the bottom next to your enter button. It's different from minus, and it might mess you up if you don't use the negative button. Okay, so inverse cosine of negative 32.0625 divided by negative 175.5. Close those parentheses, and you get 79.47. Or roughly, because they asked us, they're giving the angles as whole number degree angles, roughly 79 degrees, and that is D, right? Yeah, tricky, complicated stuff. Um, so my advice, following up on that, my advice is one, maybe leave that problem until the end to make sure that you have enough time to do it if you're on the test and you're short on time, because it's going to be worth all the other, same as all the others. But try it, legitimately try it. And the way you're going to do it is you're going to use this formula in pink here, c squared equals a squared plus b squared minus 2ab cosine c, and you're going to identify the angle, or the side that's across from the angle you're using. Put that there for C. The other two sides go there, and write them again in there. And then you have to simplify all the numbers that you have, combine these two, subtract that amount away from both sides, and then divide by what's in front of the cosine to get a ratio that you're going to do the inverse cosine of. Okay? I think you can do it. Good luck.